Mass balance problems, blended component. Two methanol water mixtures are combined. The first one containing 40 weight% of methanol and the second one 70 weight% of methanol. If 200 grams of the first mixture is combined with 150 grams of the second one, what are the mass and composition of the product? This is an example of the integral mass balance, and we have a batch process here. We start our solution from generating a process flow diagram, and we have a batch process with two inputs. The first one is 200 grams of 40% methanol is added into the flask, and it is mixed with 150 grams of 70% of the methanol, and as the result the output from the process is the mixture of unknown composition, unknown concentration of methanol, and the quantity of the final product is unknown here. Based on our theoretical discussions, we can generate three different mass balances here. The first one is the total mass balance, where we have input into the process M1 plus M2 is equal M3. So looking at the quantities, we have 200 grams plus 150 grams is equal to 350 grams, that's M3. We can have another mass balance, which is the component mass balance, and we can write down the methanol mass balance and water mass balance. One of these balances would give us the solutions for the problem. So looking at the process flow diagram, the methanol mass balance would be equal input, which is 0.4 times 200 plus second input 150 grams times 0.7 grams of methanol per gram should give us M3 times X, where X is the weight% of the methanol in the product stream. Utilizing the numbers, the masses, and the compositions or the fractions of methanols, 40% and 70%, that's the two streams going into the process, we would end up with the composition of the final product X, which is equal to 185 grams divided by 350 grams, and it is equal to 53%.